Okay, SNIA, you have fairly recently announced the Storage.AI initiative. So I guess it'd just be good to understand sort of, I guess we don't need to ask why because everyone's talking about AI, so it makes sense, but just a little bit into the background as to why now and what are the goals of the initiative?
Sure. Well, in the beginning, the Earth cooled, and then the dinosaurs came. Um, realistically, what we've been finding is that we've had a lot of work that's been going on with regards to the networks. As you know, I also have a lot to do with the Ultra Ethernet. We've got the scale up stuff for AI with GPUs and things like UA Link. But whether you're talking scale up or scale out, as sexy as those conversations are, they always assume that the data is right there. But the problem is that the data is not right there. As a matter of fact, you have to go through a lot of unnatural acts to get the data into the networks that feed the GPUs and the TPUs and the accelerators and the processors so that they can actually do the work. So we kind of assume that the data is there, but the process of getting the data there is not easy. As a matter of fact, it's very complicated. It's a non-trivial type of a thing to do. So in order to figure out how to best put the data where it needs to be, when it needs to be, we started realizing at SNIA that we had some of the pieces of the puzzle, even though they weren't designed specifically for AI, but can definitely be applied in AI to get the data to where it needs to be, when it needs to be. And so to that end, we said, well, we can take these initiatives here for the data movement. We can take stuff for GPUs. We can take stuff for, the computation near the memory. We can take, the security stuff, and we can just kind of say, well, what are the AI implications of this? And then we can create new technical working groups that deal with how to move this over networks like Ultra Ethernet, like UA Link, and say, remove some of the inefficiencies that currently exist because the data is not there. And so that's been, recently announced, and we've got a lot of people who are very excited about it, a lot of companies, a lot of individuals, and we are excited about the fact that, we've got these people coming together to solve this very complex problem. No one person or company should be responsible for having to solve this problem, and that's what's happening.
Okay, and in simple terms, is it right to say that the storage stroke data is not available for, because obviously the GPU speeds are getting faster and faster, the networks are pretty fast. Is it just simply that the data doesn't get where it's needed fast enough, or is there more complicated things going on as well?
It's it's kind of an all of the above situation, right? So it's a if you were to break down a workload, an AI workload in particular, where things get to be really messy is that an AI workload is not one workload. It's actually several workloads strung together. And each of those types of workloads requires different types of data access. So if you're ingesting the data, you need to have long streams, a lot of very high bandwidth. You have to have a lot of these things come in, from an outside source. That's a front end network, or lots of disaggregated places, object stores and that kind of stuff. Along the way, you have to convert it into different types of data and data structures so that the GPUs can use them or the TPUs can use them, because you can't just simply take object, block, or file data and just stuff it into a GPU. It doesn't work. So you got to go through this kind of, daisy chain of decision making and buffers and memory and places to hold it. And every single time you do that, you create a point of failure. And every single time you do that, you create delays. And whenever you create delays, the GPU isn't working. That's a very expensive piece of property, and we're talking about tens of thousands of these things. It's a very expensive piece of property. It's very dependent on it actually working, and at the scale that we're talking about, increases the likelihood of failure before you have a chance to actually do work. Because the problem is in these kinds of workloads, you're taking the aggregate, right? And it is the asymptotic limit to zero is that with these types of situations, you will have failures, you will have errors, and you'll have to go back to an earlier state. We call that checkpointing. But if you have to checkpoint every couple seconds, then you're not doing the work, right? So I'm a little facetious. It doesn't take a couple seconds, but it really does come down to a few minutes, right? And so if you, depending upon the size of the workload, the size of the environment, if you're just stopping your GPUs, your very expensive GPUs, often every few minutes, then you're not doing the work that you need to do. And so part of that has to do with the fact that the data doesn't get to where it needs to go fast enough or complete enough. So as we get into these really, really large systems, right, like the kind that you're talking about building up nuclear power plants, in order to facilitate, as we do that, you start to realize, well, maybe we can be more efficient. Maybe we can be more efficient in the data structures. We can be more efficient in the data movement. We can be more efficient in the networks and so on and so forth. That's what we're doing.
Okay, and I mean, it's maybe not that important, but it'd just be good to understand. I mean, is this as a result of sort of pushback from the GPU folks and the folks using the GPU saying, look, this is a major issue for us. Can you, SNIA, address this? Or were you just aware that this is a problem and therefore it's a good idea to address it before it becomes, a major issue, if you like?
Well, this is one of those moments where we kind of recognize the problem in advance. It's not always the case. Sometimes you get people coming back and pushing back and saying, "Look, this is the consequences of the decisions that we've made." In this particular case, we saw the writing on the wall a long time ago, but it's not quite so simple as to say, "Hey, here's a problem, here's the fix," right? After the fact, it's really easy to say, oh, hey, look, this is a logical, conclusion you have to draw. But in reality, there's a lot of moving parts to this. There's a lot of things that have to align. And so even though we saw it, we didn't have the ability to really do anything until very recently, partially because of the fact that the technology needed to develop to a certain point where you could capitalize on it. Sometimes you need to have the people agree in the way that what's prioritization for them. And then at the same time, you have to figure out where does it need to get done in the most efficient manner possible, because there's legal implications, there's regulatory implications and the like. So once those stars align, you can start to work.
Okay, and in terms of the stars aligning, I know you've assembled a fairly substantial amount of storage AI sponsors.
Mhm.
I don't, I'm not expecting you to name call them all, but are they in slightly different groups that you can characterize, and what's the input you're expecting over them, in terms of what they're going to bring to the initiative?
Oh, absolutely. And I think one of the key things about this whole thing is that this is a holistic problem. Right? This is not just a GPU problem, and it's not just a NAND problem. It's not just a memory problem. It's an everything problem. You've got the software situation, you've got the hardware situation, you've got the powers and the thermals, you've got the interconnect situations, you've got, of course, you've got the processors and so on. But most importantly, it is the relationship between these different devices, these different components. That means that you've got to have people who are understanding the systems. You've got to have people who understand the processing needs, and they're not the same. Like you could have one company's GPUs have completely different processing needs and data needs than their own processors, right? And so to that end, you need to be able to have a more long-term holistic approach to solving these issues. And so we've got everybody under the sun. We've got the storage vendors, the processor vendors, we've got the system vendors, the hardware vendors, the software vendors, the security people. They're all looking to find solutions for their problems where they need to talk to others who can help them get what they need and vice versa. Right. So, and yes, we had 14 or 15, companies who really blitzed through for the announcement and absolutely golden, support for what we're trying to do, but they run the gamut. Right. There's, and there's no shortage of companies that, had they had the time, would have put their names on there too. And they're joining us, to work, because the really important part is not the announcement. The real important part is the work. And so they're coming in and they're working on, and like I said, they run the gamut. They run from small startups who are just creating, their first products to well-established companies, and very large hyperscalers. So I think everybody really has a say or a stake in this kind of game.
Okay, and I think you've identified a number of projects where storage AI will make a difference, specifically relating, I guess, to some of the work groups you already have. So, can you give us a sort of flavor of if you like, which of those are the ones that can contribute, and how much? What I'm trying to say is, I suppose you've got this new initiative, but how much of it will be directed by your existing sort of working groups, and how much is this new group sort of doing completely different work, if that makes sense?
Oh, well, that's fair. So we have, I'm trying to figure out how to answer that question in a succinct fashion. A lot of it's going to depend upon the momentum and the inertia that is developed based upon the members, right? The individuals who want to work on a specific element. The good news is that many of the things that SNIA has already worked on, even though they weren't initially devised for AI, have applicability in this area. So we can actually take things that we've already worked on, either take them off the shelf or augment them or continue to work on them specifically for the AI flavor. But we also have a lot of people who are really interested in some new things. And that's not unusual. People want to work on the new and sexy stuff. So when we start to do this, when we start to go through the you know the triaging of what's really important, it's going to be critical that those companies and people and individuals have a voice as to what they do want to work on and figure out where they want to apply that effort, right? So if you're talking about the bypassing of the CPU to talk directly to the GPU, that's something that a lot of different companies are interested in. If you want to talk about how do you handle, the RDMA based approaches for these direct connections into the data sources, that's something else that people want to do. Neither one of those are existing projects, but they do have ancillary related ones inside of SNIA. So we have to sit down and talk about, okay, where do these things fit? How do we want to do this? Who wants to do this? What's the momentum and the push for these types of events? What are the things that we don't have to reinvent, right? So what are the things like data movement, for example, computation near the memory? Those are things we don't have to reinvent. So how do those kind of apply in these areas, and how do we get these two, these not two, but multiple groups to work together? And that kind of thing is the next step. So that's what we're working on now. We're trying to figure out who is going to want to push for what and in what fashion, but that's all internal inside baseball, right? So ultimately, the fact is that we have the structure in place where people can do what needs to be done without having to create a whole new legal structure or a whole new infrastructure for organization. Everything is already there and they can just start working, whatever it is that they want to do.
Okay, and in terms of the sort of end result, are you wanting to develop whether it's internal SNIA stand or SNIA based storage standards? Are you working with the IEC to produce sort of global standards? And when it is that, is it just storage, or are you looking to maybe contribute towards a sort of AI stack model or different models? Just what is your ambition, I suppose, in terms of the end result of the initiative?
Kind of a D all of the above. So SNIA is a standards development organization. We do standards, right? We do standards technology development. However, we also do architectures. We do reference guides. We do API, models that can be used that are integrated or can be integrated with other organizations' work. So, for instance, we have relationships with OCP. We have relationships with IEEE and NVM Express and UEC, and we're developing stuff for UA Link. So a lot of the stuff that they don't want to do themselves that involves data services, they can come and work with us to develop what the deliverable should be. So we will have internal data standards to do that, and then we'll have integration and operations with other organizations to make it available and cross-pollinate for the entire industry, which is, in my humble opinion, exactly what should be done in the industry, right? Ultimately, we want to be able to make things easy to provision, easy to use. We want to make sure that the administrators and the end users aren't trying to, reinvent the wheel every time they want to try to do a new deployment. And so for me, those are the most important judges of whether or not we're successful, right? So an end deliverable is only as useful as the people who use it. Right. And so from my perspective, we do much better as an industry if we keep that in mind and make sure that how we fit with other organizations as well as ourselves always feeds in service to something greater. In this particular case, definitely the way that the end users actually apply the technology in their own circumstances.
Okay, and I guess I mean we all know the AI explosion, if you like, is gathering significant momentum, and there's so much talk of where it's going to end up, in terms of density in the data inside the rack, inside the data center, etc. So just it'd be good to understand, I suppose, how quickly you think you may be, having a positive impact, bearing in mind that, as I say, that the computer networking pieces are already sort of evolving. Well, just your thoughts as to when your work brings real value, if you like, to the customers.
I think that's one of the great things about the way that we're approaching this. A lot of the stuff that we are currently working on still has value right now. And so I think what that means is that many of the things that we have been doing may not have initiated with the intent of solving problems in AI, but they do. And so once we start to think laterally about the work that we've done and how it applies to specific parts of the workload, remember, we're not trying to swallow the ocean. We're only trying to solve the parts of the problem where they exist, right? I don't want to try to solve a CPU data problem and wait on it if I've got GPU problems. I want to be able to do those two things in parallel, right? So I think one of the things that we can do is start to take an examination of the kind of work that we've already done and see whether or not that already applies. So many of the existing things have applicability right now. It just may not be the way that people have thought about it, right? So a lot of this involves some creative thinking. Um, at the same time, when we start to go through the new stuff, the stuff that's going to be, have different development velocities, you know, it will have the ability to integrate and create some sort of regression. We call this regression testing in product development, but in standards development, we do the same thing, right? We want to make sure that what we work on is going to be consistent with what we've already done. And if we need to make modifications to what we've already done, then we can still do that as well. So I think what you'll see is that we will see repurposing of some of the work that has existed, maybe for other purposes that also apply here, and then we evolve over time with some of the new stuff. So I don't think we have to wait for very long to see some really good results.
Okay, and in terms of again, it may not matter, but the characterization, I mean, one gets the impression, I say, the server folks, the chip manufacturers, etc., they're pushing forward feeds and speeds, and the networks folks talk about that as well. Is storage the slightly, until this initiative, the slightly forgotten element of the, it's compute network storage? Is the storage the slightly forgotten element until now, or is that an unfair characterization, if you like?
Oh, I don't know. I think that there's a justification for storage people feeling like the persecuted, redheaded stepchild. I'm sorry, Ginger. But the truth of the matter is that we go in cycles, right? You have these kinds of ebbs and flows of where the interest is. Back in the mid 2010s, storage was all over the place. And then, after 2020, then the network became the thing. And then, a little bit later on, the GPUs became the thing when AI became huge, right? So we go through these kinds of cycles. And I think part of it is that nobody has a 100% accurate crystal ball, right? I mean, back when we started up with, the networking conversation, HPC was the big deal, right? A lot of the stuff that we were focusing on was HPC. That changed in a heartbeat, right? Within a matter of a couple of weeks, all of a sudden we went from talking about HPC to talking about AI. And so you always have these kinds of unpredictable, changes along the way. The consistency in this is that the storage rule is very simple. Save the bit. Give me back the bit that I asked you, the correct bit that I asked you to hold on to for me. That's always been the same thing. It just so happens that how you do that based upon the workload is not a one and done, right? It's always evolving, it's always changing. And there are trade-offs all along the way. And so I don't know if it's necessarily fair to conclude that data has been forgotten. It's just that as we've been evolving through these cycles, you start to see that, oh, well, we make this work. Can we make it work better? And I think that's kind of where we are now, right? So we made the networking work better. We made the GPUs work better. Now we have to get the data into the GPUs faster and more efficiently. So I don't think it was necessarily, being left last. It was just a matter of the timing for the cycles was such that this is organically evolved in the way that it has.
Okay, and maybe finally, and a bit more sort of crystal ball gazing, if you like.
Mm.
Certain people talk to are suggesting that although obviously AI is here and now, quantum computing in terms of sort of commercial availability and stuff is not too far behind. Does that require yourselves again to sort of take a close look at current storage models, architectures, and how that responds to quantum computing, or what you're doing now, will that be able to morph towards quantum computing relatively easily? I don't know if you've got any thoughts on that.
I think at this point in time, the quantum computing is still something of a science experiment and hasn't reached critical mass for discussions. The problem is that when you start to talk about general purpose solutions, and I'm not talking about general purpose technology, I'm talking about general purpose or the widest possible applicability. Quantum computing is one of those extraordinarily small areas at the moment that hasn't quite sparked the imagination or the creativity of the industry, right? There's a number of companies that are working on some of these things that are, well, let's just say their brain power is high above my own. And so, I don't know if they've properly defined what their data requirements are. I think that they're still trying to get into the whole quantum processing part and the nature of the hardware designed for being able to move the bits around. I don't even know if bits is the right way to put that, but let's just say for the sake of argument, in our vernacular, it is. Where things start to get, kind of interesting is once it starts to reach a critical mass, what will happen then? Now, if this is something that you will find yourself needing to have standards for, then I do believe that they will probably start to explore that option. But as far as I understand right now, everything is in a proprietary format. And so I think that when we start to get into the really high quality physics and math that goes into quantum computing, a standardized data structure is a long way away, right? If I have company A that's working on solution, or so I say, um, government agency A that's working on a particular, quantum, solution, and then I've got a B version that's doing the same. The likelihood of them needing to talk to each other in order to compatibly work or conform, I don't see that happening for a very long time. Just not because of the technology, not because of the physics, but because of the people involved, because of the organizations involved, the regulatory elements of things. So the need to standardize, the need to create an industry-wide ecosystem for quantum computing is still a ways away. Eventually, probably, but probably not any time near.
No, that's fair enough. Thanks for answering that anyway, and thanks for the overall conversation. I mean, it's been fantastic to share what's going on with the Storage.AI initiative, and great to have your insights as to where it is headed. And maybe we can touch base end of the year or early next and find out what's been progressed. Because I say the AI world is moving on a reasonably fast pace, isn't it? So see
Very,
what's
very
going
much
on.
so. And it's always great to talk to you, Philip. It's fantastic.
Thank you so much again for your time. Appreciate it.